All right, so let's begin. Where was I last time? Status. Okay, so there's some changes to Scratchpad. Yeah, we were testing the symmetries. Get diff staged. Let's make this full screen. So here we just kind of like deleted the false true true stuff. Wait, no, sorry. What am I saying? We took these three lines and we moved them. Wait, what? I guess we moved them here and then we called horizontal transformed or something. And we deleted these three false true true stuff. And then basically we're kind of like renaming stuff. Like from horizontal, we're kind of just calling the transform. And we're just kind of like, we just kind of changed those numbers a bit. Status, so that's what's staged. Get diff. Diff is just, we just like tested out like the, okay, that's fine. So basically we're kind of like more or less done with let's just open up Scratchpad. And let's take this whole thing here and let's just comment this out because so this block here I guess just kind of like debugging and verifying policy and value gives us a policy, and then this kind of GSN, and GSNN are like our canonical three game state like example that we're like working with for testing. And this block that we just commented out is for like we just tested the symmetries on transform game state. So then I can just kind of like, yeah, so then the next step is to like use these same things, maybe like let's say the last one, and test it for the transform policy, right? And inverse policy too. But they're the same, so I think it only makes sense to test one of them, right? So anyways, let's just like first of all let's just commit what we have. Status, get add all, get diff staged. Okay, so then symmetry, no, here's our get diff. We just kind of commented, add comments, and everything else is in comments. Okay, get status, get commit, add commented block, commented out, or commented out block, or comment, comment out block, testing, symmetry, transform game state, status. Okay, great. So now we have that. Okay, good. Drink some coffee. So what next, right? Okay, so here's our leak code nonsense from last time. Now let's go back to our kind of our game state. So this right here is GSNN, right? Let's just kind of let's just take GSNN like this thing here, and let's just like kind of like recopy it a bit elsewhere, right? Let's just take this and let's just kind of reproduce this, right? Some coin here, and then a coin that's a bit kind of out a bit, like a bit kind of odd one out. And then here, here, here. So basically, like this one and these two are kind of like the odd ones out, right? And then so now let's just give this a policy, right? So right now it is like P1's turn. P1 moves this coin to here. That's P2's turn. P2 takes their king and moves it till there, right here. So here's a start. And P1's turn moves this coin here, ends up here. Now it's P2's turn. P2 takes their king, moves it here, ends up here. And now it's back to P1's turn, right? So like, what's a good policy, right? Um, I think that there's kind of like, let's say like kind of two ideas here. Wait, here, here, or moved it here, and then kind of here or here or here. So if I were playing this, I would have three candidate moves in mind. One is take this coin here, it's P1's turn, right? And move it here, kind of like doing that, right? The other one is take this and kind of launch it here. Is there? I'm checking this picture to see if there's an obstacle in the way. Kind of like here, kind of moved here, and then here, or kind of there. Yeah, I mean, if you're launching up here, and if you launch down there, like we're not going to cross this horizontal line because it's just inverse of that component. Or we can move this coin, right? So that's two candidate moves. One of them is like kind of so then like and then kind of here's my like third move, right? So I'm going to consider this as a so let's see. So this is coin zero, coin one, coin two, right? In terms of like the indices and game state coins. So let's just kind of be very because I feel like the way I personally play bumper coins, again, like this is not like the meta, this is just like my meta, or like what I like to do is I like to have like one coin to be the invader, like one coin to infiltrate the enemy camp, and I like to have one coin like kind of stay near the king for some defense or maybe mid. But like yeah, I like typically like the king is kind of like hidden. Might have one defender and like or like and then like kind of like one attack. It depends on the layout of the obstacles actually. In open positions, like attacking, well, never mind. Let's not get into bumper coins theory because it's still kind of in its infancy. But yeah, I have seen like in like courses with like multiple many obstacles, like positional play there is a very like I've seen players like just be defensive gods and just like kind of like bait their opponent into like attacking and like controlling strategic areas and mostly playing defensively until they basically kind of like kill off all the invading coins and then just simply like counterattack and just crush their opponent, like just toying with them. So like defense is important, but I guess like since there's lots less obstacles, maybe we might see more exciting games. In fact, like exciting or like kind of games that finish faster, I think are like kind of at least from the perspective of training are kind of nice because like like games are faster. It means we have like less training data, so it's like longer games mean we have like more training. Never mind. Okay, let's just go back to topic, right? If we're gonna create a policy, then we're gonna convert that policy. hmm So let's say that we have like 40% here, like 40% here, so like point 0.4, point 0.4, and then what's the remaining thing? Point 0.2, right? Point 0.2. Actually, you know what I should do? Let me take this arrow, and let's just kind of make it a bit smaller, right? Like half the I already played again in Lee Chess and I kind of like explained my thought process. Point two, right? So now, when and this is like coin of zero, zero, one, two, three, four, exactly. And this is like, or actually, instead of that, let's just kind of like note this is kind of like zero, and this is a zero, one, two, right? Just like the indices of the coins, right? And then when we flip it, and once we horizontally do the flip, once we flip the coins horizontally, then how does it going to look? I mean, we can kind of like, oh wait, no, we don't have it. Well, this coin basically goes here. This coin goes here. And then it's kind of like this thing. Our desired policy is a 0.2. And this top coin, that's a bit like odd one out. So now, like this coin, 0.4 and 0.4, right? So this is basically like 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 what is a policy, right? Like these three edges, these three arrows with the weights are policy, right? Just like that. So now we're just like going to test the policy, and let's start off with the horizontal case, right? Okay. Should we open a policy? For game state next, right? Okay, so let us begin. Let let moves and probabilities equal an empty thing. Moves and probabilities dot push. What do we push? So let's start off with the same order we drew them. This one first, right? 0.4. New move. Okay, so what is the move, right? Coin ID. The coin ID. And then the move ID is going to be a 0. And then that. Yes, I know it's a bit redundant, but that's fine. So then we get the move ID of the 0. Maybe it might like benefit us to have a helper function that like takes in a coin or a coin ID and a move direction, just gives us a new move instead of just the components. But no, forget it. Doesn't this stuff is like splitting hairs, don't even matter. Like that. So the coin ID, the move ID, and then using the move ID would derive the directions, the VX and VY, because those are strictly a bijection, strictly mapped one to one with the move ID. They're synonymous. Only reason we include them, like include both, is to get the code to work with both repos. When I say both repos, I mean both BumperCoins, like the physics code particularly, which expects the move object to have the velocities, and then the ID should work with like the connect for like the net.ts and train dot like whatever like the training. Like it's useful to have this move ID which is kind of analogous to like the column ID in Connect 4, where like we kind of use that when it comes to like converting between the policy and the tensor, like the action vector, like the output of the policy head tensor, right? Where it's like from a vector, a tensor of like size 2400, right? 2400 is a number of move directions is 8 times the height is 15 rows times 20 columns is 2400. So like that like flat vector is like our policy head output. And to understand like the policy, we've talked about this several times, like similar to how like AlphaGo does it, or like I guess like AlphaZero for chess, like the encoding works. Like you have a bunch of like image, like not the like image stacks, but not like we're not talking about image stacks in the context of the game state discretization, but rather the move discretization, like how to represent all the moves, right? Like well, let's say it's like just as a refresher, right? For AlphaZero in chess, like the queen, right? The queen can move in like 8 directions, right? Up, down, left, right, and like and same thing, but like shifted for the diagonals, right? Right. So that's why you'll have like 8 extra image planes, 8 extra images stacked together. Where like actually wait, it might even be more. It might even be like no, it's not just like the number of directions, but also like the magnitude, like how far the queen moves. So it'd actually be much more planes, right? Like it would be like one plane simply means that like the value at like entry I, J, or whatever coordinate means you take that piece there, that's a queen, if it's a queen, and like you move it like one step in this direction, then one other plane would be 2 steps in another direction, 3 steps. The point is that like everything is being kind of like all possibilities are kind of like being accounted for. Actually, why am I talking about this? I mean, I've already kind of mentioned like a lot of times, even in the earlier streams. I dedicated a whole stream to this, in fact, like the input, like the output representation of the neural net for BumperCoins, and like the reason why, and like the whole point is like because of the way the representation is, it's really helpful to have a move ID because we multiply that by 300 to get the like offset, right? In the in this vector, in the policy head vector, right? In fact, let me open my notes. We're going to actually like talk about this a bit later, actually too. But anyways, back to my code. So we have moves and probabilities, and then this is like saying, hey, we take the coins of zero, which is this coin here, and we move it with 40% chance, with 0.4%, 40% in this direction, which is direction move ID 0, and then that, right? And now let's kind of like copy this, but now we're gonna move this in what direction? This direction right here is 7, right? Like 0, 1, 2, 3, 4, 5, 6, 7, and then 8 wraps around, ace num directions, right? So then this is gonna be 7. Likewise, we have to propagate those changes. Wait, what did I just do? Sorry about that. No, this move one, this should be 0, and that should be 0. Okay, so now again, coin 0 ID, and now the move ID is 7, 7, 7. Okay, yes, correct. And now what we're gonna do is instead of coin 0, it's coin of 2, right? So now we have coin of 2. Actually, let's just delete that. Copy this one. So now we're doing coin of 2 with move ID 0 again. And the direction should be correct because like we copied from there. And the only difference now is make this last 0.4 a 0.2. So now 0.4 plus 0.4 plus 0.2 equals 1.0. So that's good. All the probabilities sum to 1. And now let us create a new policy, right? The constructor is just takes in that. Let policy equals to new policy of this thing, right? Just like that. Okay, let's do a quick compile test. Good, it compiles. Okay, so now what do we want, right? Now let's like test horizontal symmetry. So these things are going to be the same. We're not going to change those lines, hopefully. So now we have a horizontal symmetry, and then let's let policy transformed equals symmetry dot transform policy. I think that's what it's called. Policy of transform policy. Wait. Hold on. Let me just open up symmetry again. Transform policy. Yeah. So it's transform policy. So transform policy does not take in the game state. It only takes in the policy. I mean, yeah, because you're only like manually flipping the move IDs. That's literally all you're doing. Wait, no, and the directions too, right? Okay, how does transform policy work? Oh yeah, I remember. It's two steps. Like one step is negate the correct, the relevant velocity, and then the other one is do the move ID. Yeah, very okay. Yeah. Yeah. Okay. Yeah, no, this is definitely correct. So then transform the policy, and then let's do Okay, so now the question's like, how do we actually like test the policy? Like how do we test? So now we have the policy transformed, and like how do we like test to see like, because like when we're testing the game state transformations, we had a print method, right? Should we have like a print method there, like a JSON print object JavaScript? What's it called? JSONify? Wait, what? Stringify? Oh, JSON.stringify. Okay, good. Console.log JS backtick string sub interpolation template. Okay, so that's how you do it. JSON.stringify the policy transformed JSON.stringify the that. Okay. Okay. So let's see. We have moves and probabilities. So let's do it again just to see the move ID change. Actually, no, never mind. So you have some ID, right? 41 is a coin of zero, move ID, and Vx, let's just kind of accept this as that, and Vy is zero. So we're only moving in the X direction, right? And then again, same coin, move ID is 7, right? So we're moving it southeast. And then its BX again is has like some in the X and some in the Y. Recall that if Y is positive, that means it's southern. It's going down actually because of how the axis is. I've talked about this many times. And then here's our last coin, F1. So 41, F1. It's just 4 and F basically. So then coin F, we're again moving 0. Again, whenever we see 0, we know it's 4666 and like VY is 0 with point 2, right? And when we transform it, let's see here. Coin 441. Again, this coin right here, 41, refers to this coin right here, right? Like this is now like this is the coin, right? We don't actually we're not like changing this coin's um how do I say this? This object here, like or this policy is for this coin, right? But then when we like this coin ID, like when we call transform game state, what we're doing is we're taking this same coin and we're kind of like doing 20 minus X, right? So like we're like taking this raw, like this whatever this coin object is of ID 41 something, right? Like 41B whatever. We're taking that coin in transform game state, which I've already tested, and we're basically moving it like here. So this coin becomes this coin, right? It's the same like raw, like the same coin object, the same ID 414 whatever. And now like the policy is for this coin, right? It means this coin, right? So this coin, we should expect to see what? The move ID is 4, and then like negative X components, so yeah. So here's 4. The move ID is 0. What? Coin ID 4. The move ID is 0. The VX, VY. What? No, that's wrong. Wait, did I substitute it? Wait, what? Why is that? This one should not be 0. It should be 4. Okay, let's see the next one, because that's the exact same thing as the previous one. Same one, coin 4. Move ID 7. Okay, now it's 7. Wait, what? This is literally the exact same output as like, what? Okay, so there's a bug. Okay, time to open up VS Code. Let's put a breakpoint in our transform policy. Scratchpad. Right here, right? Okay, well let's debug this. Wait, return p.clone. Oh, it's symmetries of 0. I am so dumb. I am actually mental. Okay, never mind. I shouldn't say that. You have to make this R1, right? Yeah, so I was just doing the identity policy. Well, great. We verified the identity policy. That's wonderful. That's pretty nice. Okay, good. Status, get diff. Yeah, see, it was symmetries. Yeah, so I just had to change that. Okay, that's all. We were doing the identity symmetry. Okay, that's good. They're same. Okay, so now let's compile everything again, and let's just run it. And yes, the ID did change. So now it's C6, and the other one's CC. Okay, so C6, CC. So then C6, move ID 0, some X, 0Y, 40%, then same coin, C6. Then move ID 7, a bit of X, a bit of Y, both positive because, you know, because X positive means go east, but then Y positive means go south because the Y axis is upside down. Then coin ID CC, the bottom left coin, not the top left one. Move ID 0, and then a bit of an X and 0Y, 20%. Now when we flip it horizontally, and the first coin is now move ID 4, which is correct, right? Because that's exactly what we want. Like this ID is 4. Again, the move IDs, just in case no one is like, if this is our origin here, this is going to be 0, that is going to be 1, that's 2, that's 3, that's 4. It's like the legend. This is 5, this is 6, and this direction is 7, right? So this one is direction 4. So this one is direction 4. Its Vx is negative because we're now going this way, and Vy should still be 0. Vy is 0 with 40% chance. Okay, good. Then this coin ID is C6. Great. Its move ID is 5. Okay. So now it's saying going here is 5. 0, 1, 2, 3, 4, 5. That is correct. And now its Vx should be negative, but then its Vy should still be positive because we're going down, right? So Vx is negative and then Vy is still positive, 40%. Good. Then the last one, CC, let's predict its direction should be also 4. Should be the same as that one except 20%, right? So the last one is coin DCC. Move ID is 4. It's that thing is negative, but then Vy should be 0 and then 20%. Okay, good. Same as the first coin. So this seems to be pretty good. So now get status. Let's just do a get add status. Great. Um, so now let us kind of to do the other directions. So now that we've done symmetries of 1, let's do symmetries of 2. And before we run it, before we actually run it, let's kind of like draw this map. If we were to take these policies, and let's kind of like do it vertically, right? Let's just test it out vertically. So here we do a vertical transformation. In fact, I think we might have, no, this is a horizontal and vertical, right? So okay. In fact, notice that we don't care about these coins anymore. Like we only care about like the coins for player, because like right now we care about like the policy means only player, so like here, right? Player one's turn, player two's turn, like player one makes a move, player two makes a move, and now it's player one's turn to make a move. So he can only move these 3 coins, right? So it's like for the, so anyways, so then if you transform vertically, then this coin, like it'll stay on the left side. This will still stay the same, but then this coin here will kind of go up a bit, and then it's still going to point like 0.2, and this coin here will kind of be like that, and then it will kind of like point here with a 0.4, but then it's going to point here also with 0.4. Actually, you know what? Maybe I should change this to be like zero point 0.3 and this one to be like 0.5. So they're all kind of different. In fact, I think because like Point 0.4 and point 0.4 might be a bit of like, symmetry or something, or like a bit of ambiguity. Like now we're tying each direction in coin tuple to like a unique probability intensity. So okay, so now let's just like make that change right now. So this one from direction 0, from direction move ID 0 is now going to be made 3, and to compensate we make this one 5, right? So let's just actually quickly let's make the symmetry back to 1. Quickly retest horizontal again. Okay, so 2D, move ID 0, 0.3, right? So let's kind of look at that in here. 2D, move ID 4, correct, 0 to 4, and then Vx is negative, Vy is that in 0.3, correct. And then the next one for 2D is move ID 7, and then positive, positive, which means southeast, 0.5, and then let's kind of see what happens here. So 2D, move ID of 5, so then from this one, move ID 7, it becomes move ID 5, right? This one flipped about there becomes this, right? So like this one here, 7, becomes 5. So that is correct. Negative x, which means we're kind of like going a little bit more, and this one should be 5. And that one should be 3. This looks terrible. So this one of move ID 5 should be 0.5. Move ID 5 is 0.5, negative x, and then positive y, which is consistent, negative x, positive y. So 0.5. Let's go back to the 0.3 one. 0.3 is move ID 4. Yeah, so move ID 4 is 0.3, and it's negative x, 0 y. It's a negative x and then 0 y. Okay, good. And the last one should be unchanged, right? This one is just 4, which means it just goes like that, but with 20%. And compared to the last one, right? Which is same coin, 8B, move ID 0, bit of x, and then 0y, 0.2. Only thing we do is we take this x going right, going east, and we make it flip the sign to make it going west. Okay, good. Status, get diff. Yeah, we just kind of change them to be unique. Get add all, status. Okay, so now let's test the symmetry back to, we did horizontal just now really quick. Now let's do vertical. And let's not look at this and quickly go here. So we're doing vertical, right? So, okay, let's delete these wrong weights, wrong probs. Okay, good. So now this one, the horizontal one is 0.3, and the diag towards the center is 0.5. Okay, so now let's test. This one, 7C, move ID 0, that 0.3, correct. Same thing, but now it's 7, which means southeast. Then move ID they're both positive 0.5. We've seen this a whole bunch of times. And then the last coin is 4 instead of 7, and then move ID 0. Same thing as the top one, except it's 20%. Now see how it transforms. Now this one, which was at the top, is now at the bottom in the transformed flipped version. And then this is the 0.3 one. So now it basically has the same direction, right? It's the same direction, and then basically same thing, right? So what I'm saying is that like this 1.3, right, basically doesn't even change. Like it doesn't change. So that's correct. And now let's consider this one, right, with 0.5. How does this change? This direction is 7, and now it should flip to direction 1. Like this one here becomes this one. So the move ID should change to from this direction is 7, it should become 1, and then its component should also change too in some way. Like something should be flipped. So then here, we just saw the first one. So now this is 7, and now its move ID is 1, Let's highlight that, which is correct, right? This is 1, and then its Vx is positive, and its Vy is negative because it's kind of going uphill, right? Its Vx is positive, and its Vy is negative, and then kind of like the inverse of that, where the Vx is positive, the Vy is also positive. So instead of like going move ID 7, which is southeast, it's now going northeast because the negation negative sign on Vy makes it go north instead of south. And the east-ish is still because the Vx is positive, so that's good. And the final one, let's delete those two circles, is comparing this arrow to this one. So it's basically the exact same. Like the only thing of interest was like this thing, because like stuff that is on the x-axis, right? When you flip vertically is going to be the exact same. Only something with a y component gets said component negated, right? Because a negative of 0 is just 0. So yeah, same thing. This one still remains 0. It's Vx, and it has some going east, and then Vy 0, 20%. Okay, good. Status, get diff. We just kind of like change that to 2. Let's just do get add all. Okay, now for the final test, we're testing the horizontal and vertical, right? Clear. Okay, and now let us do the final thing, right? And I think we have it right here, right? So this coin here, or actually, no, never mind. Okay, let's just kind of, okay. So now we have to flip these coins horizontally and vertically, right? Let's take this coin here. Let's flip it horizontally, so it ends up here. Let's flip it vertically again. It ends up there, right? And then where's arrows going? Well, one of them is kind of going this way with a 0.3. Let's put the 0.3 in the bottom. And the other one is going that way with a 0.5. And this one, let's flip horizontally. It would end up right here, vertically, no change. This one we flip horizontally to end up like somewhere here, or somewhere here, and then vertically up there, right? And this one should be 0.2. Okay, so now let's do the comparison, right? So now we start off with like, so then, oh wait, never mind, hold on. Okay, good, I just wanted to clear that arrow. Okay, so now now we start off with this arrow here, right? For 0.3 should end up here. Same coin, only difference is this arrow becomes this and the sign gets negated. The Vx gets negated, right? So let's look here. Coin E2 has move ID 0, some positive x component, 0y, 0.3, right? So this right here corresponds to that, which is correct. And now let's take that same coin. So then after the next one, actually transformed, now we have to kind of copy it and compare it to this one, right? To this one right here. So this 0.3 is still 0.3. So now what I'm highlighted should kind of be consistent, should match what's drawn here. So we have something with 30%, which is 0.3. Same coin as before, E2. Its move ID is 4. So like first the move ID was 0, right? And it becomes 4. And then there's a negative x component. And then the Vy is still 0. So that's correct. So then this thing and that thing have been checked for horizontal and vertical. Now let us consider this arrow, the 0.5, and see if it matches this one, right? So again, let's highlight this first one right here as 0.5. This is the same coin E2, move ID 7, because we're going down here. We've seen this quite a few times. Its Vx and Vy are both positive and both the same, southeast, right? And now when we flip it, or now let's highlight what it becomes, the second one from policy transformed. So now it's the same coin, E2. Its move ID becomes 3, right? So this one here, let's check. Yep, 0, 1, 2, 3. So this direction, which is northwest, is 3. So now it's northwest, northwest, 0.5. So 3. Yeah, I have the highlight all the way here. The highlight should go on here. Let's just kind of do that again. So this coin, same thing, E2, move ID 3, 0.5, and move ID corresponds to what, right? The VX is negative because it kind of has a leftward component, and the VY is also negative. Negative because it's going up, right? So negative, negative. Whereas first, it was negative, positive. Positive, positive. So flipping both X and Y basically flipped one of them and with the other one. So from positive, positive, we get negative, negative. And then the move ID becomes 3, right? 3, negative, negative. Because negative means we're going west, and then this negative means that we're going north, because again, the y-axis is flipped. Okay, that's good. And now the last coin, right? The last one, I mean, we know, so now what we're doing is we're comparing this one with this one. Okay, so then it should be the same as similar to that, right? Just the only thing we did is flip the x, because flipping the y doesn't have any discernible impact because there is no y component to flip. So now from 0, we expect it to be 4. Right? Oh, I already highlighted it, right? So now from 0 it becomes 4, and then Vx is negative, Vy remains 0, 20%. Okay, good. Get status, get add all. Actually, let's go back to our scratchpad and let's kind of comment this out. Symmetry is using a policy for... So I think we did that. We haven't tested inverse policy, but there's no point testing it because, to be honest, the inverse policy is the exact same thing. Like if we look at the symmetry.ts and we look at the inverse policy, because like symmetry has like two things. This one, like transform game state, transform policy, and transform inverse policy, right? And when we like have the constructor for a symmetry, we pass in the transform game state lambda function, transform policy function, inverse policy. But whenever you look at where we actually create symmetry objects, where we call this constructor, we only call it in these 3 lines, right? And whatever argument we put for flip policy horizontally, like this argument here, second one, is always the same thing as third one. Flip policy vertically, flip policy vertically. Flip policy horizontally and vertically, flip policy horizontally and vertically, right? So basically, we've already tested just now, like, that these flips policies functions are correct, right? Like, these 3 functions we have tested as correct because ultimately, like, we've tested this factory as being correct, and we've kind of like tested this where like one, we negate the appropriate component of the move, either Vx negate or Vy negate, and then we do some like math to get the move ID function to like, we also like do the same corresponding flip for the move ID. And I've already like, we've talked about that like several streams ago. And the key kind of insight is that like, for many of these kind of flips, like flipping horizontally, flipping vertically, and flipping both, these kind of functions are their own inverse. So you only have to test one direction because we get the inverse for free, actually. So in fact, I guess we're more or less done with our testing we just commented that out, right? So now let's kind of like do git add all, git status, git log, git commit, comment out block testing symmetry transform policy, get status. Okay, so now like Scratchpad has some kind of commented out stuff where I kind of like tested, where I just went ahead and tested some symmetry operations and like visually and like looked at the console output and kind of convinced myself that like the symmetry seems to be doing what I want it to do. So that's pretty good, actually. That's great. In fact, I think I could just like call it a short stream and just kind of maybe even stop here. Yeah, it's pretty short, but yeah. Let's kind of go here. And now policy symmetry testing. Let's delete that one. Let's make this title next streams, kind of like the to-do. And then I will just end it here. So yeah, that's all for now. Short stream.